Hi, everybody. This is Anna Hackman from Green Talk, and today I have the pleasure of interviewing Yoav Efron, and he's with Toeprint Energy Group, and he's going to walk us through today with a presentation about Easyliner, which is an energy-conserving device for reactive power generated by motors. It's very interesting. It's not as complex as it sounds, and today we spent a lot of time together about how some of my clients can save energy with a lot of their motors, which would be like HVAC, chillers, refrigeration, so on and so on. So, welcome.
Thank
We
you.
just saw each other just not too long ago. I actually have gotten the pleasure of meeting him and talking a great deal about his product. And I'm going to flip right now to the PowerPoint so we can get right down to business. One second, hold on. Okay, there we go. Okay. Yoav, go ahead with, I'm on your first slide and it talks about Toeprint Energy Group. Tell me a little bit about your company.
Well, first of all, Anna, thank you very much for having me. It's a pleasure and a privilege to be interviewed here. Toeprint Energy Group is an energy services company providing energy conservation, energy efficiency solutions to buildings that reduce cost and improve several other things within the facility, taking a holistic approach to all the loads, all the electrical loads that appear in such a facility.
So we're going to get right into the presentation. I'm going to go to your slide two so you can tell us a little bit about Easy.
Sure. So, yes, Toeprint Energy Group is an affiliate of Energy Automation Systems, a 33-year-old company that has been in the energy efficiency business for all that long and have had multiple dozens of thousands of installations already under its belt. The main premise of what we're doing is reduction of electricity consumption and therefore reduction of electricity cost. And the byproducts of these also are reduction of heat in system equipment in the facility in general, reduction of maintenance, the necessity of maintenance for several of those equipments that are being used, and improving the quality of the power consumed in the facility.
So
With
let's go through. Sorry to interrupt you, but people are when they think of energy reduction equipment, they're thinking more efficiency, different things than really what this product does. I mean, it does the efficiency part, but talk about exactly what does it do? What is it? How am I going to save money in my facility by using your product?
So maybe if we move to the next slide,
Okay.
I want to show what you see here as a continuum, basically, of all those areas in the electrical consumption system, if you may, in any building. And by the way, we're focusing here on commercial, industrial, government, schools, hospitals, hotels, etc., public buildings that would mostly reap the benefits from that opportunity. So we're looking at five main areas. Four of them are basically the areas of consumption: refrigeration on the left, on top machines and or AKA equipment and motors, heating and cooling devices, systems, and lighting. As a side component that has opportunity, we always can do energy procurement through alternative suppliers.
So give me the specifics of what this product does.
Yeah. So actually, I think it's a good segue to the next slide, where we can talk about specifically phenomena in the electric distribution system in any facility that generates losses. So one type of loss is reactive power around motors. So this can be canceled or offset by a certain device that actually I'm going to show you tonight.
Now, tell me a little bit about what is, and we had this discussion before this podcast and videocast. It took you a while for you to explain to me what exactly is reactive power. What is it?
Simply said, there are two types of power going through any distribution system: real power and reactive power. Real power is the one we pay for and we consume from the source, from our utility company. Reactive power is generated within the system as a result of magnetic fields, for example, in motors. That reactive power we don't pay for. However, it's not totally consumed, and therefore it goes back into the distribution system and creates resistance for that real power that we really need.
So does that mean that I'm paying more for my power because it's harder for me to actually get the real power that I'm trying to generate?
That's correct. We are actually the system requires more power to be consumed for the loads that are in the facility, whereas you could take care of some of that reactive power waste and loss and remove resistance so that that consumption you just mentioned is going to be reduced.
So is that generally the case in older buildings, newer buildings, older motors? Is there a rule of thumb that you've noticed with certain buildings having more reactive power issues than others?
Well, it will exist anywhere where equipments and machines exist. So refrigerators or machines in manufacturing environments, or any cooling and heating electrical machines that are operated by motors, they will have that, and practically everywhere you would have that. But that is not the only phenomena that creates loss and could be treated.
Okay.
Another one is harmonic power that exists around nonlinear equipment. Nonlinear equipment is those, for example, that are operated by variable frequency driven motors.
Is that like Wi-Fi or no?
No, harmonic power is swings of power that are driven by the fact that the motorized the motor that operates that system has variable frequencies, variable speeds.
Okay, a variable speed motor, like what you'd find in a lot of manufacturing plants.
Manufacturing plants could be in elevators, could be in escalators, could be in yes, even in air conditioning and cooling systems
Right,
as well.
right. So how does that differ from reactive power?
Well, I think we're getting very technical, but it's a different type of distortion to the AC sine wave. So I think that for the benefit of our viewers, we can continue through, because that would be something that the difference would be something that would be
Too complex?
to actually explain in a nutshell.
So in general, it's just another source of power that's causing you to pay more.
That is correct.
Okay, go ahead to your third one.
And not only, by the way, not only does it cause us to pay more, it also causes increased maintenance, because harmonic power is disturbing the operation of the motor and actually reduces its lifespan.
Yeah, I was just going to say that when you were talking about that's what was the first thing that came to my mind is also loss of machinery.
Right.
And that's expensive.
Exactly.
Go ahead to your next one.
The next one has a myriad of elements within. One of them is probably very, very easy to understand, because it's usually a very low-hanging fruit for many people, which is retrofitting light bulbs. That is as easy to do as 1, 2, 3 to many people, including in your home. So adjusting power demanded by lighting starts by as easy things as removing incandescent or other forms of over-consuming lighting bulbs and replacing them with energy-efficient ones. But it doesn't stop there. It continues with other phenomena like controlling and managing the voltage that is feeding those lighting devices and systems by making sure that there are no surges and they are suppressed, or there is a control device that controls that voltage during its operation. And in many cases, especially in commercial and manufacturing environments, you would have, especially in hotels, for example, hospitals, etc., 24/7 operation of lighting systems.
You know, that one area, because we didn't really off record didn't talk a lot about that, and I'm still a little confused by it. Can you just give a little bit further explanation as to what that means by transient voltage surges? What is it that your machinery can do to reduce that?
Well, it identifies, and again, we're getting a little bit too technical, but it identifies those distortions in voltage levels above and below the expected current that is supposed to feed the lighting system, and smoothing it out throughout the day, throughout the hours.
Oh, I get you. So it's when it's just those spikes.
That's an easy way to understand that. Yes, that's
Okay,
correct.
go ahead to your next one.
Another form of loss is just aged HVAC systems or aged refrigerators, where those systems are operated through compression of refrigeration liquid, and that compression needs to be lubricated. That system needs to be lubricated all the time. That lubrication deteriorates with time, and it's typical, or it's expected. However, it doesn't necessarily have to stay this way, because you could improve that without changing or replacing the system to a brand new one. But you can design, or as we can custom design, an additive that would renew life and remove those and improve the lubrication, so that when the cycle is on for that HVAC system or the refrigerator, it would be more efficiently reducing temperature, so that the times between cycles would be lengthened, and therefore electricity consumption is going to be reduced.
Now, when you said you would develop an additive, is that meaning that your particular product, which is would be the same type of product that you would be using for the other systems?
No, and by the way, when we were talking about several of those phenomena that create waste here, there are multiple products that we have been going through here. What I'm going to show you today is just one of them.
Oh, okay. Okay.
So that additive could be in the form of a liquid that would take care of that compression and improve it. Of course, that the motor that operates that HVAC or refrigerator systems could enjoy a reduction of loss from that first section that we reviewed on reactive power.
Now, before you get to your last one, you're going through a lot of different items here. I know we're trying to keep it more of an overview. Is there a place on your website or on EASI's website that people can click and find these specific different types of treatments that they have?
Absolutely. ToeprintEnergyGroup.com has a very comprehensive overview of the areas where that impact could be inserted into the building, as well as an overview of those technologies and how they work, as well as on EnergyAutomation.com. There is a portfolio description that goes through product by product.
So they can be as technical as they want to be. There'll be information that will make everybody happy on those websites.
Right, but I have to add that for the sake of being effective, with the vast experience and with the guarantee that is being provided for the payback with the systems that we install, that we implement, their effectiveness has been proven beyond any doubt. The important thing is to focus on, okay, how am I looking at holistically my facility and reaping the benefits from each side into a packaged or a holistic view of how does it look to me, and most importantly, how does it look to me as a facility owner financially, making sure that we don't just want to make a better world and consume energy better and more efficiently. We want to make money and make sure that our investment is paid back quickly and is sustainable for years to come, which is exactly the case here.
I interrupted you when you were going to do your last one about lighting and equipment running together to become more efficient.
Yes, sometimes there is an effect on lighting power quality driven by adjacent equipment that could be operated in a certain way. And again, without getting too technical, those operations, such as a variable frequency operation, for example, could create a negative effect on lighting, not only waste, but also other forms of flickering or those types of interferences that produce the quality of that lighting, of the light coming from those lights.
That's really interesting.
Yeah.
So let's go on to the next slide.
Yeah, a few words about energy automation, as I might be repeating a few of these points, but 33 years of experience, since 1978, that include a proprietary technology and really a best-in-class engineering expertise, coupled with the fact that that technology portfolio is the most holistic in the business. In other words, it takes care of all those forms of losses that we went through, and is really so that really is a portfolio that stands out. One of the greatest things about it is that it's all passive. In other words, it is a technology that does not interfere or affect actively anything in the facility, any operation of any machine or equipment, so that nobody is feeling that it might take a risk, because we will never we will never ask anybody to take an operational risk, nor, as it says here, nor will we take any technological risk with products that weren't qualified. But for those products that were qualified, they're not forming any operational risk in terms of a fear of downtime or anything of that nature. And furthermore, it's what I call an install and forget. Passive products that do not require maintenance and renewal or refresh, even after 10 or 15 or 20 years. They're there, and they operate as long as they're on, and they're on all the time. There is no way to turn them off unless a certified electrician will have to do that. Then they do their job way years and years after the investment has been paid back.
Now, speaking about doing their jobs, how would a facility manager know? I mean, of course, we're going to get into that a little later, but how would they know, let's say, that year's up or that 3 year is up, and how would they know that they're continuing to save money? Is there some sort of product that you have with this that allows them to see real-time savings?
There is a very tight process of performance verification post that implementation. We're using IPMVP, which is an international standard protocol for measuring results.
Can you say that again?
IPMVP, International Protocol for Measurement and Verification.
Okay.
And that protocol is being used very, very carefully, including taking into consideration electricity consumption, and which is pretty much looking at all those nitty-gritty details in the electricity bills that come every month, and comparing them year to year on comparable seasons, but it doesn't stop there, making sure that this analysis is adjusted by price changes, by degree days between years, because some days are cooler or warmer on the same date, and consumption and tenant occupancy, as well as production. So facilities could decrease production year over year. They could increase or decrease occupancy. Things change. The world is dynamic, so all those things need to be inserted into that analysis to make sure that the verification is exact.
And how long do you verify for?
Typically, we would verify up to 12 months after implementation, and if needed, we would do more. In many cases, after a very short period of times, customers would come back and say, "We get it. We don't need to verify it anymore because we can see the savings very clearly."
But what I was saying is, after that 1 year, if they want to, sorry about that. Take this. If they want to know if they're earning, what they're earning in real time after the 12 months, how would they go about doing that? Engage you guys to continue verifying it, or can they use some sort of system to be able to verify it?
Well, IPMVP would work on analyzing electricity consumption, the real numbers. So it's the proof is there rather than in an external system, because these are the numbers you pay your bill based off of. So if needed, we would go beyond 12 months. Usually not required, but if needed, we will go that route.
And I see that you have a savings guarantee backed by Lloyd's of London. Can you explain that?
Sure. When we once we run a survey and understand what is the consumption consisted of in a certain building, we provide a proposal, a design of a system, and that design includes where electricity is consumed, how it's consumed, how does it break out, what are the opportunities, and how does it measure up in terms of percentage savings, and what does it mean in terms of how many months does that translate to in terms of return of investment. That number of months that we commit to, it's not just we commit to, Lloyd's of London is backing us up on that commitment and saying we can back Energy Automation, Toeprint Energy Group, we can back them up that return period is going to be actually happening, so that if anyone has any doubt, and if that wouldn't eventually happen, then Lloyd's of London is there. I can just put a side note that Lloyd's of London never had to pay any difference or execute on that guarantee, because the approach that we're taking is so tight that we live by and we never miss. So, but it's there, and it's part of that system design and that guarantee commitment and that payback commitment.
And it's about a 3-year payback?
Typically, people see 24 to 36 months of payback. So there is a good chance that it's actually going to be less than 3 years of a payback.
Oh, so your estimate's pretty conservative.
When I say less than 3 years, I mean faster than 3 years.
Right, that's what I mean. That you tend to be when you guys do your analysis, it tends to be more on the conservative side. So you have seen that it's been actually quicker for some people.
Right. So the conservative approach is just a prudent approach, making sure that it's never missed, and many times that committed payback and that committed savings are being exceeded.
Let's go on to the next slide. Okay.
There are. I'm not going to go through each and every line item, but there are some important things that stand out, that needs to stand out to the reader, that would explain why it's worthwhile acting upon and improving this facility or this building and creating those efficiencies. Other than, of course, we talked about reduction of energy, and that happens day one, and it pays itself back quick. You can stop time, which means that every month that passes by, that money, that operating expense is gone because your bill is paid to the utility or to the electricity supplier, as opposed to reinvesting that money and starting to do something about it to reduce it for the long run. And Eventually, it becomes a competitive advantage because many companies and building owners are getting into the sustainability planning, getting into their master planning that include a lot of, okay, how do we treat our energy infrastructure as a strategic asset and not just as a cost of doing business, which is how people should be thinking, and that becomes a competitive advantage. And there are a myriad of other things that you can see here of why is it important right now. Toeprint is an affiliate of Energy Automation with that vast confidence and focus on we're doing something that has to pay itself back. It's not just for the sake of the environment. It has to go hand in hand together. So it has to have a payback, and it works. And when we mean it works for so many times already, and it will continue working for many other dozens of thousands or hundreds of thousands of cases to come.
Now, I'm on your slide 7, which talks about the process steps. Can you walk us through quickly of how you go about assessing a building? And then I'm sure everybody wants to see you show them how this system works. So let's do this quickly and then go right to the test that you showed me in the afternoon. It was phenomenal. So again, walk me through the process steps real quickly, and then tell me when I need to go to the next slide.
Sure. Very quickly, we'll go through those 2 slides. It starts by introducing this solution and explaining it, which part of it we're doing today, and then we would walk through a facility and understand those unique characteristics of that building, that facility. We were capable, once we get that and we get some electric bills. And we can look at it and analyze, see whether we see anything in the bill, because there are certain things that would tell us what's going on in the building from that bill. Once we get that, we can come up with a very quick initial assessment, which is actually a guaranteed initial assessment, conditionally, of percentage savings off of electrical expenditure. That would be binded by a survey agreement or a conditional agreement here that says, let me do a survey. Let me survey and inventory the entire list of loads and measure them in the facility. It has a nominal fee, but that survey is going to give us all the information we need to design the perfect system with the optimal savings opportunity in it. If I can't reach out to my initial assessment of percentage savings, that survey is for free. Once we're done with the survey, and I'm jumping through, but the survey has a lot of components to it, on-site and off-site, using the engineering expertise in energy automation and with Toeprint and its partners, where we can go ahead and design, or we can go ahead and design a system, custom design it to that particular customer, and come back with a recommendation. That recommendation would include where, how much, why, what can be done about it in terms of electricity consumption. Very analytical, very detailed, so that the customer understands and there is a clear communication of what is recommended and how it's going to affect the customer's environment. Once there is agreement, and we have and there is an opportunity to include, of course, the guarantee, which is most of the times included in the solution, we go into installation of that solution. Again, since it's passive, we're trying to be invisible and do it as professionally as possible without interfering the operation of the facility, and complete it as soon as possible. Once that installation is done, we're ready to go for savings verification, and that's where we start monitoring month in and month out how is consumption affected, starting with the full month of electricity billing that has the post-installation completion. And we do it, as we said, for months until we're convinced, until the customer is convinced that what we have promised has been has been delivered.
And typically you're seeing what kind of savings?
Our customers see typically savings between 10 to 25%. As I said, we're conservative on the commitment, the initial commitment, so it would be on the low end, and with a very likely opportunity to exceed.
So when you have someone who looks and gets the 10%, does that mean it's kind of still with the same payback because you guys knew that going into the actual installation?
Absolutely, absolutely, because that initial commitment would have to tie back to an expected payback period from a customer. If a customer has a threshold of 36 months, and nothing is going to be approved if it pays itself back by more than 36 months, we will have to work extra hard to make sure that even that conservative estimate would return itself in 36 months. And hopefully, if that solution exceeds the percentage savings, therefore, that payback period will be faster.
So let's go to the videotape. Let's go see how this works. I'm going to put you back on screen, and I know that you've set up a little demonstration for us. So hold on one second. I'm going back to Skype.
I'm going to rearrange the computer so that we can see.
No problem. We'll hold on.
So I hope let me know if this works.
Yeah, I see it.
Okay. I will have to lean on a little bit. But what we see here are three main things. We have 200 feet of wire, which kind of represents the distribution system, the wiring. It represents miles and miles of wiring throughout the walls of the facility. The bigger the distribution system, the more losses are incurred, which is why it's important to include that. We see here a representative motor. It's a quarter horsepower, but don't worry. The energy automation portfolio, the products could scale up to very, very large machines. But that's just for representation. It's a typical, it could be a machine, could be a chiller, a compressor. It could be anything that exists in the facility. And what you see here is one of our products called the Easyliner.
Are they all that size, or are they all different sizes?
There are different sizes, but many of them are as small as that component, and those are not products that would interfere with aesthetics or be intrusive and too big to live with in a facility.
So where do you put that box? When, let's say, you've got a chiller or you have an HVAC system, does it sit right by the machinery? Is it on the wall? How does it all work?
Could be on a sub panel. Could be next to the machine on the wall. It depends on the design, but it is very easy to kind of put it in a place where it doesn't bother anybody that is in that facility all the time. I would plug my for just the sake of I would put that on the floor, and I would plug it to an outlet so that I can operate my machine.
So is this plugged into the sub panel or to the machinery? Is it bypass the sub panel?
No, the products are as close to the machine, and they would be on the line side. That's the only relevant element of where they will be installed.
And does condensation have any part to play with those machines? Will that matter at all if you have an area that has some condensation going on?
We would find the solution of where to put them. I don't believe that it would be a major issue, because usually those mechanical rooms are pretty big, and relatively speaking, those products could be very small as opposed to other things that are there. So, and if they need to be outside, they could be put in stainless steel enclosures that would allow them to be in
Okay. And I know that you had mentioned before that sometimes you can do more than a couple machines with one of these, units. So if you have a lot of like compressors or you have a lot of motors together, you can use one for a lot of them.
It could be done. It could be done, but it depends on specific cases where, for example, multiple motors are operated at the same time, switched on and off at the same time.
Okay.
Then there's an opportunity to put them to reduce their losses through a different product that will take care of multiple loads at the same time.
Okay. So go ahead with your experiment.
I would plug in that motor, and you might hear it starting to work. I hope that it doesn't interfere with how you hear me.
No, very little.
Okay, very good. So that motor now works. It doesn't, as you can see, it doesn't operate anything. And what I'm going to do is I'm going to use a clamp. That's a clamp, and I'm going to take an amperage read, an amp read of that motor. So the amp read of that motor is, I hope you can see it.
No, I can't. But just tell us what it says.
So it's 4.4, 4.5 amps. And
Yeah, I still can't see it. I guess because the glare from it. There, I got it a little bit. Just so everyone knows, I've actually done this demonstration, and what he's going to be showing you, even if you can't actually see it on the video really well, it's true, what he's going to tell you, because I saw it from my own eyes.
Thank you very much, Anna. So what it read is, and it read it on both sides, it read 4.4, 4.5 amp at 60 hertz.
Okay, go ahead and see if we can see it. Do the same thing you did with your hand over the over that, I think. Yep, there we go. We got it. Yep, I can see it now. You don't even use your hand. It actually it picked it up.
Oh yeah.
Yep, got it. Okay.
So now what happens is I took this measurement before that socket and after that socket. So on both sides. That socket in the middle is in order for me to hook in the Easyliner. So I'm hooking it in, and you would notice that there's no impact on the motor operation. So I hooked it in. That motor still works. Nothing changed. And I'm going to take a reading now towards the load.
So even with this product, it doesn't cause the motor to work less, or it doesn't take away from its effectiveness, right?
Correct. Nothing changes in that motor operation. That is absolutely correct. Now I'm going to take a reading, and what I'm going to see is that motor still draws 4.5 amps
Okay.
at 60 hertz.
Okay.
You can see it.
Yes.
So it's the same thing on the other side, on the opposite direction. However, if I now go to the source side, that means I'm going to take a reading between the Easyliner and the source that goes to our meter, the source that determines where our electric bill is determined. I'm going to take that reading, and that reading is now significantly lower.
Does that say 1.8, 1.7?
Exactly. That says 1.7, 1.8 amps. It is a significant reduction. It's that significant. It's a little bit exaggerated, I must say, because that motor is not doing anything. It's extremely inefficient. However, it's still going to be a significant reduction when it's operating, maybe in the 10 to 20% range, as I said. However, so that significant reduction is driven by the fact that between the source and my motor, I connected an Easyliner that took care of all those losses that we reviewed when we talked about reactive power.
Now, have you ever or heard of through the company where you have something like this where there's such a major difference that it may warrant you to say, you know what, you guys might want to replace your motor, or is it instead because of your product you've been able to save that old motor from having to be put out of business and put in something else?
Well, first of all, replacing a motor is going to be much more expensive, and second, even the new motor is still going to have the same phenomena unless it's a very sophisticated one. You could argue, however, that is going to it's going to have the same electric loss phenomena when it's replaced. So that is exactly why we were focusing on that fundamental level of taking care of losses without replacing, forklifting existing expensive equipment.
Have you found that because the company's been around so long, have they prolonged the life of a lot of the motors?
Actually, yes, that's correct. So in certain cases where there was extended wear and tear, energy automation definitely found many cases where life of motors are prolonged. You're correct.
One thing I wanted to ask you a question on, because everybody, and you and I talked about this as well, is really hyped up on renewable energy. And with renewable energy, there are motors. I mean, there is inverters for solar. There's geothermal has a motor. So this is also for them as well. Am I correct?
Absolutely. If those renewable energy systems, like a geothermal system, would have to be pumping water all the time. So this pumping activity has to be operated by motors. So there is an opportunity there to help that be more efficient. Yes, I agree. Yeah, the answer is yeah. Maybe on a solar system, you don't really necessarily need anything but that solar system itself. However.
But there's an inverter, so that's why I don't know how inverters work. If it's a motor, I would assume that there's electricity, so I would think that might be something that would make it a little bit more efficient and last longer.
I wouldn't believe so. The inverter might be a very small device that is operated resistively without any motor need.
Oh, okay. Now, you've given us some great information, and what we try to do with this podcast and videocast is to give more of an overview of the product. So people are going to have a lot of questions. Tell everybody how they can reach you.
The easiest thing would be to log into www.toeprintenergygroup.com and register, and I'll be and that registration reaches me directly. It also includes my phone number.
Now, when we talked earlier, most of your work is in the Northeast. Am I correct?
Most of my work is in the Northeast. That's right.
However, you have access to a tremendous amount of other affiliates who work with these systems, and you could direct someone to the right person, right?
Correct. We have a vast network of affiliates all over the country and in 60 countries outside the U.S. that is reachable, so we can work together to cover any remote locations that would be desired to work on. Absolutely.
This is great information. I mean, when you showed it to me, you probably were watching my mouth and it dropped open when I saw that big difference between 4.2 and 1.7. So even though I know that this is not the most ideal situation with that motor, it's still going to be significant. And it's a no-brainer with distribution costs as well as electricity costs. People forget they don't just pay a kilowatt price, they pay a distribution cost. So this takes that part out, right?
That's absolutely correct.
So it's kind of a double whammy.
Yeah, and it is significant. I think that as a percentage of revenue for many businesses, energy could be the second biggest operating expense after people. And that impacts cash flow and operating income for a business, and that's very significant, even if it's 5%
Right.
reduction.
But what I liked about your product was not simply, well, of course, I liked that the fact it's going to save energy. What I was really fascinated about is the fact that it would allow for aged equipment to last longer, and that's extremely green.
Yes, absolutely.
And no one likes, like, remember when we were walking around my hotel client and you're like, oh my God, we'd have to rip that, someone have to rip that out or rip this out. That's time maintenance, landfill, the whole bit. So
Yeah.
it's really, that little machine's a little wonder there.
I actually heard a real life example where, in the case, for example, I heard about an office building that had to replace a compressor. So not only that you have the cost of a compressor that's an expensive expenditure, and it's usually happens when you least need this to happen, right? So Murphy laws work against us, and you need to spend that money without much notice. But you also have to, because it's an office building, you have to fix it off hours or on a weekend. So that overtime paid for maintenance people to replace the system is extremely, extremely expensive, and it makes the entire experience very hard for that property manager owner.
It was a pleasure talking today. I mean, I was so excited when you showed me that, the demonstration a couple hours ago, and I thought everybody has to see this. And I'm so glad that we were able to get a quick video and a quick podcast put together, so everybody can see what I saw. Any closing words?
Well, thank you very much, Anna. I enjoy Green Talk tremendously, and I follow it every week.
Thank you.
I think it's a great contribution to the communities around us and to the area, and so I thank you for the opportunity, and I'm looking forward to making improvements one building at a time.
That's good to hear. And with that little machine, that's definitely going to do it. Everybody, this will be on Green Talk. It will be in a podcast, a video cast, and I'm probably going to have it transcribed because this information is pretty technical, and the last thing I want to do is get it wrong. So look forward in about, it'll be on the site probably in a couple weeks. And thank you again, and best of luck. And I'm sure you and I will be talking in the next months, weeks to come about your project.
Thank you very much, Anna.